Hi everyone, in this video we look at graphing the exponential function f of x is equal to b to the power of x where b is greater than 1. So in A we're told to plot f of x is equal to 2 to the x, and in B we're told to plot f of x is equal to 3 to the power of x. So let's go ahead and we'll make a table of values for 2 to the power, y is equal to 2 to the power of x. So we've got x, and this is going to be y is equal to 2 to the power of x. And let's go ahead and we'll plot a bunch of, or we'll try to figure out what y is when x is, like, I don't know, negative 3, negative 2, minus 1, 0, 1, 2, and 3. So when x is negative 3, y is equal to 2 to the power of negative 3. 2 to the power of negative 3 is just 1 over 8. 2 to the power of negative 2 is just 1 over 4. 2 to the power of negative 1 is just 1 half. 2 to the power of 0 is 1. 2 to the power of 1 is 2. 2 to the power of 2 is 4. And 2 to the power of 3 is 8. So this gives us a bunch of ordered pairs that we can plot. So let's go ahead and we'll plot those ordered pairs. So let's first go ahead and we'll scale this graph. Our first coordinate is negative 3 comma 1 over 8. So negative 3 comma 1 over 8 is very close to the x-axis. Negative 2 comma 1 quarter is about here. Negative 1 comma 1 half is our next point, and it's about there. Then I have a point at 0 comma 1. I have another point at 1 comma 2. Another point at 2 comma 4. And another point at 3 comma 8, which is right here. And then we'll go ahead and draw a smooth curve through all those points. Oops, okay. As smooth as possible. Okay, and as you can see that as these x values, they get further and further to the negatives, we're going to get smaller and smaller numbers. But our graph is never going to touch the x-axis because we can't get a value of x such that y is going to be 0. As I plug in numbers that are further into the negative, I just get smaller and smaller values for y, but I don't get y values that are negative. So this graph actually approaches a horizontal asymptote. That horizontal asymptote is y is equal to 0. Now let's go ahead and we'll try to come up with, and this is the graph. I should probably label my graph. My graph is f of x is equal to 2 to the power of x. And then we'll plot the graph of f of x is equal to 3 to the power of x. So again, we make a table of values. This will be x, and this is y is equal to 3 to the power of x. When x is minus 2, we have y to the power of negative 3, 3 to the power of negative 2, rather. 3 to the power of negative 2 is just 1 over 9. And when x is negative 1, 3 to the power of negative 1 is just a third. When x is 0, 3 to the power of 0 is 1. When x is, when x is 1, 3 to the power of 1 is 3. And when x is 2, 3 to the power of 2 is 9. So let's go ahead and we'll plot these points. And scale the graph, or scale the grid. So I've got a point at negative 2 comma 1/9. I also have a point at negative 1 comma 1/3. I have a point at 0 comma 1, 1 comma 3, and 2 comma 9, which is here. So you can see that as we get smaller and smaller values of x, or not smaller, but as we get further into the negatives, the y value decreases. But it never goes to 0. So we never get a y value of 0, and we never get any negative values for y. So we can go ahead and draw a smooth curve through this graph. And the graph should approach the x-axis, so it looks like that, but it never touches the x-axis. So we have a horizontal asymptote on both these graphs at y is equal to 0, and I should draw the horizontal asymptote with a dotted line on this graph as well. Okay, so now let's summarize a couple things about this function. So for let me write this in a different color so that it's a little bit brighter. So for f of x is equal to b to the power of x, and where b is greater than 1, let's think about what the domain is. So the domain for the graphs above, we have that x can be any real number. So the domain of our function was the set of all x in the real numbers. And then our range was the set of y in the real numbers, such that here y has to be greater than 0 because we have a horizontal asymptote. So the graph never comes down and touches the x-axis. So we have that the range is the set of all y in the real numbers, such that y has to be strictly greater than 0. So it can't be, we can't say that y is greater than or equal to 0 because the graph never comes down and touches the x-axis. So let's also note that the y-intercept for both of these graphs, the y-intercept was 0, 1. The x-intercept does not exist, so no x-intercept. So there's no x-intercept. And the equation of the horizontal asymptote is y is equal to 0. So we have a horizontal asymptote at the y-axis, or that is the y-axis. And another thing to note is that from left to right, this function is increasing. Okay, so the function, we also have that the function increases from left to right. Okay, and lastly, we have that our key points on both of these graphs. Normally, when you're plotting exponential functions, you try to plot as many points as possible on your graph to make your graph as accurate as possible. But I would say to try to plot at least 3 or 4 or 3 to 5 points. I try to plot 5 points, and just so that I can draw my graph as accurately as possible. But sometimes those 5 points are not always going to fit on the grid. So we've definitely got a point for our y-intercept, which is 0, 1. We've got another point at 1, b. We have another point at 1, b squared. And we have another point, if we go to the negative values, we have a point at -1, 1 over b. And we have another point at -2, 1 over b squared. In the next video, we're going to look at what happens when b is between 0 and 1.